académique. Et aujourd'hui, on aura l'opportunité de découvrir la question des services dans l'économie spatiale. Nous prévoyons aussi d'aborder la question du militaire spatial et de présenter un projet particulier européen, notamment en lien avec l'université de Saint-Étienne et le laboratoire ubercurien, notamment, mais je vous en dirai un peu plus prochainement. Donc, je vous invite à réserver déjà votre date du 23 mars dans votre agenda. Et n'hésitez pas aussi, si vous sentez de devenir speaker ou intervenant expert sur le sujet, d'apporter soit un sujet de contribution, soit même d'intervenir directement lors de ces sessions. Quelques news. Principalement, aujourd'hui, la grosse actualité, c'est le lancement du plan de relance spatial. Comme vous le savez, au niveau de la situation de la crise sanitaire, l'État fait plusieurs démarches en termes de plan de relance. Le spatial en fait partie, avec une déclinaison qui s'opère en plusieurs volets. Aujourd'hui, vous avez certainement vu déjà le volet B, principalement qui peut vous intéresser, qui est une série d'appels à projets collaboratifs qui ont été mis en place et que vous pouvez voir sur la page du CNES. Vous pouvez retrouver aussi les informations sur le site de Minalogique. Donc avec 5 grandes thématiques, donc les SATCOM flexing processés, la communication optique, la virtualisation en segment sol, les terminaux et l'économie de la donnée. Sachant que la finalité les clôtures de ces appels est assez proche de mémoire, le 5 et le 12 mars pour ces appels à projets. Le deuxième volet qui nous intéresse, c'est le volet C avec des pitch days. Donc, il y aura une série, il y aura un space tour qui sera organisé à travers la France avec le CNES, notamment en pilote et en lien avec les différents ministères et avec le soutien des boosters sur les actions territoriales. Le projet de ces pitch days est de favoriser l'émergence de solutions répondant à des problématiques, à des thématiques qui vont être prédéfinies. Tout n'est pas encore calé aujourd'hui, mais l'idée, c'est de définir lors de ces pitch days différentes dates à travers la région, à travers la France, dans les régions, qui permettront de mettre en avant 3 entreprises start-up permettant d'apporter des solutions applicatives en lien avec le spatial. Donc avec, comme vous pouvez le voir, des prix relativement intéressants pour le trio de tête qui sera de 100 000 euros, 75 000 euros et 50 000 euros. Voire une opportunité d'avoir un abondement avec des projets régionaux. Je vous en dis pas plus aujourd'hui sur les pitch days. L'information devrait bientôt arriver sur les lancements des dates et des thématiques retenues. Mais vous pouvez déjà être dans les starting blocks et n'hésitez pas à revenir vers moi si l'information, si le sujet vous intéresse. Je vous ai mis sur le côté des micro-slides, c'est juste pour vous dire que la présentation de ce plan de relance qui englobe plusieurs informations aussi un peu plus exhaustives, notamment sur le plan aussi en lien avec les nanosatellites, est à votre disposition, donc n'hésitez pas à me contacter pour que je vous le fasse parvenir. Quelques infos très rapides. J'avais déjà abordé le mois dernier sur le PIA3 régionalisé, le R&D Booster. On commence à rentrer dans les dernières lignes droites pour pouvoir être accompagné et favoriser la qualité des dossiers. Donc, pour rappel, sur ces appels à projets, nous avons un programme d'accompagnement, donc avec la demande faite par Minalogique, c'est d'obtenir au moins une première version du document que vous envisagez de déposer dans le cadre de cet appel à projet le 10 mars, pour réserver aussi une date d'audition, soit le 19, soit le 23 mars, et vous permettre d'avoir un dossier le plus exhaustif, complet et de qualité pour le 31 mars, avec bien évidemment la labellisation du pôle. Idem pour le concours Innov, l'idée étant de vous accompagner sur ce concours qui est aujourd'hui un SAVAC 7, sachant qu'une des thématiques est la deep tech, c'est celle qui correspond le plus potentiellement à des projets en lien avec le spatial. Donc avec une date attendue des dossiers le 24 avril, pour une audition le 4 mai, et pour vous permettre de déposer avec la labellisation du pôle le 11 mai au plus tard. Quelques rappels aussi sur les appels à projets académiques, donc pour les montages en vue de monter un projet européen, donc le MRSEI. Éventuellement, si vous aviez un projet de chaire industrielle, n'hésitez pas à revenir vers nous de manière à ce qu'on puisse vous accompagner au mieux, au moins vous mettre en relation ou vous soutenir pour une lettre de soutien sur les projets que vous envisageriez de monter. J'en ai fini pour ma part. I'm finished. I will let the floor to Andrei to speak about the services for space industry and to speak about space application and the Ice Cube services. So Andrei and Alexander, the floor is yours.
Thank you very much. Can you hear me well? There's an echo. Yeah. All right. I'm assuming that it's all good, so I will begin. Thank you. Yeah, so rethinking services for the space industry 4.0. Before I zoom in and I dive into what IceCube service is doing, I would like to share this overview with you, with this snapshot of the space economy. This is the 2019 overview. Hopefully the data from 2020 will come soon. So, okay, we don't have time to dig into all the details, but I would like you to see how 3/4 of the space economy is basically comprised of the satellite industry, which was one of the first branches to be commercialized. And then also, I mean, when we talk about space exploration, we always think about a launch, but actually the launch services segment is very, very narrow compared to the rest. So I guess the main idea here is that, sure, it's a snapshot, so it's not a dynamic representation, but it would be very interesting to see in the following years how this segmentation will change and how various sectors will evolve. For example, you see here a very, right next to launch services, it's a very narrow niche of commercial human space flights, but there are already 2 commercial flights to the ISS planned to be taking place later next year and beginning of next year. And yeah, so it's going to be very interesting to see how this landscape will change with more commercialization. So when we talk about space industry 4.0, what does it mean? I guess you all know what the industry 4.0 means, the so-called unfolding fourth industrial revolution. So when we talk about space has also been through various phases. So we could consider space 1.0 as being the age of astronomy. If we call it the modern astronomy, we could start from Galileo, for example, and then space 2.0 would be the phase where emerging spacefaring nations up to the Apollo program, and then space 3.0 would be the era of international collaboration and cooperation and the building of the ISS. And nowadays, we say that we are in space 4.0, which comes with a lot of substantial and significant changes in the landscape. So space industry 4.0 is where our terrestrial fourth industrial revolution meets space applications and space activities. So just some of the main trends and themes that are changing the landscape. Of course, it's not an exhaustive list, but we talk about exponential technologies and disruptive innovation, and not just it's basically a combination of tech and business. How can we provide new models and new applications using all the tools that we have now? We see more and more private investment and commercial markets. The public is more engaged, and we call this the democratization of space, because access to space is growing, and so more and more people are being involved, either directly or indirectly. Another important thing is the wide range of new players, and we talk about small countries that join the space race or space competition. We talk about institutional players and governmental, but also non-governmental. We also see a number of non-space sectors and services that are slowly joining space activities. And this also comes with a changing role of space agencies, because space agencies have to move from the traditional roles to more modern and adapted to the market roles. So there's a lot of push from the industry to enable commercial activity. So they are pushing for creating new markets, and various agencies and governments are implementing public-private partnerships to develop space capabilities and infrastructure. So science and space exploration are being used as drivers for economic growth and through economic development, so that we build an infrastructure that can sustain long-term exploration. And these market opportunities and future markets could be organized in various ways, by category or by destination. Here you can see just some of them, the most important ones, somehow organized by layers. If we start from suborbital to orbital and deep space, and sure, some of these markets already exist, like remote sensing and communication and research applications. But there is this, right now, there's this phase of commercialization of low Earth orbit. So the low Earth orbit assets are slowly being transferred to the commercial sector, so that agencies and governments and large organizations can actually focus their resources and their attention to deep space exploration, or the moon and beyond. So in orbit, some of the most important things that are in the making are probably manufacturing and repair stations and servicing stations. If we imagine a platform that would be able to service satellites, it would refuel them, it would upgrade them or extend their life. And this will change the landscape in the low Earth orbit and higher orbits as well. And then, of course, in deep space, this will take some time, but we're slowly getting there. Now there is a lot of momentum there's a lot of momentum around going back to the moon and establishing commercial activities on the moon to have a sustained and sustainable presence. So slowly converging to the main, let's say, the core topic of rethinking services in a changing landscape. So we talk about servicialization and spatialization, how we call it. So space companies nowadays have to adapt and move just like any other companies in other sectors, industrial sectors on Earth. So we have to take into account reusability. And here, SpaceX basically changed and is changing the paradigm by landing and reusing rockets. Repeatability, by doing the same thing over and over again, lets you learn faster and implement the things you've learned. And miniaturization, the things that have been happening on Earth for decades now. This is why our devices in our pockets pack so many instruments. This is also happening in the space sector. And everyone is working towards low-cost systems and low-cost access to space to reach economies of scale and affordable technologies. A lot of COTS components, so commercial off-the-shelf components, are being used nowadays. The processes are shorter, the research and development and the delivery is shorter because the tools enable that. There is also a transition from cost-plus models to fixed-price models, which stimulates innovation and then drive. And also everyone. One of the desired goals is to reduce bureaucracy and to simplify procedures and processes to implement things faster. And then there is also more an openness towards risk-taking, because this is innovation without risk-taking is not really possible. And of course, space is not space is still an expensive adventure, but with the cost benefits and cost-benefit considerations and looking at space as a venue for business, things will change gradually. So space for space and space for Earth. The point here is that the ISS and the assets in low Earth orbit can be used for both terrestrial markets and future space applications. So We do space research for actual space to prepare for going to the moon and Mars. Here we use the ISS as a test bed. The International Space Station is still the most important test bed in space, and it's our laboratory. It's becoming more and more crowded and busier. But also we use space assets and microgravity for Earth. And this is also very important. And this is something that needs to be communicated more and more towards general public. How space is actually being used to improve life on Earth and to benefit Earth research and development, and how microgravity is slowly being integrated into value chains. So part of the servicialization part and rethinking the services in this new landscape, as I said, space companies have to look out and be aware of all sorts of elements and variables. So we have to constantly scan for new opportunities and markets, because commercialization of low Earth orbit comes with increased competition and a more dynamic environment. Space companies also have to think about branding and advertising and communication strategies. Who do you talk to? How do you talk? And of course, marketing and positioning and education in multiple senses. So of course, there's educational programs when you transfer information and knowledge to younger generations, but there's the educational part in the sense of raising awareness about space assets and space advantages. So, and of course, within a public-private partnership, the agency, as I mentioned, is playing new roles. So it's also playing the role of a customer and a business partner and an advisor or consultant. And the IceCube service, which is a commercial service provided by, well, the mother company is called Space Application Services, has been around for more than 3 decades. So in a way, we're not really new space, but we are embracing some of the new space principles and the general philosophy. So IceCubes is an end-to-end service, meaning that we try to make, and I will show you some examples later, we try to make the life of our customer as easy as possible. So that's why we provide an end-to-end, meaning that we take care of the whole process from beginning to actually getting the experiment on board the ISS. Here you have a picture of our facility. So we own this facility inside the space station, inside the Columbus module. And this is where we send these customizable cubes where the experiment is placed. Of course, I mean, we call ourselves IceCubes, which stands for International Commercial Experiments Service. But of course, the payloads can come in various, in other sizes and shapes. So that's 1U is the standard unit. And we provide regular access to the ISS. We fly every few months when there's a resupply mission to the ISS. So we usually fly with the SpaceX. And we offer spatialization because we address a lot of non-space sectors. And of course, non-space people and experts in general are not familiar with how things are being done to get to space. So it may be scary or it may be disarming. So that's why we want to make it as simple as possible, so that the researcher or the investigation partner can focus on their research, and we take care of everything that happens outside the cube. So once the payload gets on board the station, it's being plugged into the facility, the one I showed you earlier, and then the customer gets unique, actually near real-time interaction capability. So they can monitor and control and actually change some of the parameters from home, because they have their own interface and their own tunnel. It's cost efficient. We try to make it as affordable as possible. And of course, the IP rights are owned by the customer. And we operate as a global service. We have presence in the US as well, and we are an implementation partner to the ISS National Lab. And of course, as I said, the IceCube service was born as a public under a public-private partnership with ESA. So I will not go through all these characteristics, but what's very important about microgravity is that, you know, things behave differently in space, and it's very interesting to see how we can actually understand life better when we leave its cradle. So we go to the ISS to do research on various if we talk about life sciences, then you can obtain 3D cell aggregates without the scaffold. We see accelerated cell growth and increased virulence, gene expression alterations, and crystals actually grow larger and faster. And I will show you a little bit about the protein crystallization service. And then, of course, for physics, because without gravity, I mean, not completely without, so in microgravity, without convection, you can actually build and obtain defect-free, almost perfect surfaces. So this is very relevant to material sciences and fluidics and physics and technology and in general, and wide range of applications that can use this this environment. So here is just you know, a list of fields and segments and industries. Call them how you want to call them. So in the area of life sciences, there is a lot of research being done for pharma and drug development, for biotechnology, organ on chip, protein crystallization, as I said, because proteins grow larger and actually you can obtain near perfect crystals, things you cannot really obtain on Earth. And of course, 3D bioprinting and medical devices and various things that use the advantages of microgravity. And of course, as I said, in the area of materials and physics, additive manufacturing is will be one of the most important branches if we actually manage to print and to build things in orbit. Along a wide range of possible applications. And here to show you some examples of what we've flown and what are we working on at the moment. So it's pretty diverse. So from greenhouse to some inspirational artistic projects, a cybersecurity project, the protein crystallization, which is actually under we have a partnership with a Japanese company, and the service is called Kirara, and we've flown already two cubes, 2 missions, and we have educational payloads and other banana disease experiments and diamond magnetometer. So it's pretty wide, and we're working on some very exciting experiments and payloads as we speak. So I will slowly, I will use our AI because we also develop some in-house capabilities. I want to talk a little bit about artificial intelligence and machine learning on board the ISS because it's one of the, let's say, the hot topics and one of the activities that will impact most, if not all, segments and the way we do things in space. So it would be things are already in the area of artificial intelligence, things are already changing. I mean, of course, on Earth, the applications and the advantages are obvious, but using AI algorithms in space, so in orbit, sometimes is not very obvious. So why would you do that? Because it helps us simplify the infrastructure and to reduce mission costs overall, and you can extend battery life and to because there is this, when I get to some more concrete examples, I will tell you how and why. So it basically can enrich your capabilities and boost your capabilities and unlock new types of applications. And this will also speed up commercialization. And using testing AI and machine learning capabilities in low Earth orbit will basically help us implement more advanced techniques for deep space exploration. So these are just some of the ideas and opportunities that we've come across or thought about while with the IceCube service, we are not AI people ourselves, but the facility on the ISS basically allows us to have this capability permanently hosted on the ISS. for various types of applications. So just to give you some big examples, like robotic assistants and devices to basically to support activities and to support astronauts in their daily activities, and AI-assisted medical care that would create a profile of the astronaut, for example, and it would monitor various parameters like cardiac heart activity or mental health evaluation through facial expression recognition. Here we have a picture of Simon, basically a robot, a smart robot developed by IBM with Airbus. Other examples would be for radio frequency systems and for big science data processing, because orbits are getting more and more crowded, and then the number of assets is also growing fast. So then the amount of data that is being generated is growing fast. So there's a need to simplify these systems. So a lot of data could actually be processed in orbit on board the spacecraft, so that the downlink and uplink will be reduced drastically. And of course, Earth observation, which is a very important and very big branch of space activities, and we use it almost every day. There is a lot of potential for the use of AI in space here as well. And of course, educational STEM activities where students of all ages could use the assets of space to learn about space, about technology, and to implement their projects. And to start to create a bridge towards Alexander's presentation, there's also a lot of potential in the area of augmented reality and virtual reality using our AI capabilities. So imagine, Alexander will talk about digital twin, but imagine using AI and augmented reality and virtual reality to enhance and improve situational awareness, and to have a more dynamic relationship with your environment. And we could be talking about wearables or emergency medical procedures or smart astronaut suits. If you think about, I used the picture of Tony Stark, but imagine future astronaut suits having this kind of information coming to them in real time on their visor, related to what's happening around them. And the thing is that the farther you go from Earth, the more autonomy you will need to have, because just a couple of days ago we saw the very successful landing of Perseverance. So that part was just fully automated. So if we can do that already, imagine what the future might look like if we implement AI capabilities into our space infrastructure and space assets. Because so now with the commercialization of low Earth orbit, this is a perfect opportunity to test and to try out new things. And then as we move towards the moon and beyond, then the need for autonomy and self-reliance will grow. No matter if we're talking about human-machine partnerships or just about robotic missions, there is a very long list of challenges and opportunities that could be addressed, improved, and maybe even solved by using AI capabilities. The assembly of the lunar gateway will start soon, and then we will slowly, hopefully, establish permanent presence on the moon, and then we can move beyond. The moon will be literally our gateway towards the rest of the solar system. So we need to use all the resources and all the techniques we have at hand to make these things happen, because it's exciting and we need to do it. So I guess there's always a lot more to say, but I will stop for now and I will pass the floor to Alexander, and looking forward to hearing your questions and anything you want to ask. Thank you. Take it away.
Yeah, thanks, André. Thanks for the transition. So I'm Alexander Bolton, CEO and co-founder of Nucleus VR, and we're actually a industry company. So we're not a space company, even though we're getting into that business. And definitely, IceCube service is a good way for non-space companies to get involved. As they say, they are a facilitator. So we're developing COTS, a commercial off-the-shelf solution for Industry 4.0, which has as a purpose to create digital twins and to use them as a virtual workplace. Just a second, I'm getting my timer set up. So the idea is our system is very useful for in the situation now where it's not necessary to travel. So the way it's used is basically you have this 3D representation of your asset, and everybody in the company can connect up, whereas they are like supervisors in the office, but also people on the shop floor. So you can imagine the people on the shop floor being astronauts and the people in the offices being the guys at, say, for example, ESA back on Earth. So our main domains, we are Industry 4.0 and also very active in the nuclear industry, which is very big in France. So we're part of the Nuclear Valley business cluster, so to say. So we got kind of in touch with some people in space who said, "Oh, your solution would be great for space." And at first, my reaction was to say, "You're kidding me! Space? That's just too complicated, or we're just too small." But after thinking about it for a while, we thought, well, yeah, why not? So we put together a use case demonstrator using our commercial off-the-shelf solution, just using our basic tool. So basically, the idea is to connect astronauts on board with experts on Earth using the digital twin concept. So this presentation was sort of based on a Apollo 13 scenario, which you can see in this picture here. Basically, everybody knows the fact where they had to fit a square filter into a round hole, or the opposite. I'm not quite sure, but there, in this case, they used what I call a physical twin. They had all the equipment in the lab in Houston or wherever in the States. They built the solution physically with the components and shared it with the people on the space capsule to fix it. So we built this solution, and we got it. This enabled us to win the ESA Inner Space Masters contest. So that was about 2 years ago now. So that was like really a big accomplishment for us. We are very proud of this, and it got us involved in space. So Natalie, if you can launch the video. So this is an illustration of exactly what the tool does. So I'll let it run in.
The International Space Station is a highly complex system consisting of hundreds of subsystems.
Remove the sound, Natalie. Thanks. Yeah, so the space station is extremely complex.
The International Space Station is a highly complex system consisting of hundreds of subsystems. In order to maintain this complex system, the expertise of a wide range of engineers and specialists is needed to assist the work of the astronauts on board of the space station. Currently, the crew members on the ISS communicate with the Earth-based teams by voice radio and reference guides. This situation is not ideal, since it is inefficient and creates risks, uncertainties and stress. ISS crew members need to be able to quickly and easily access and exchange information with the Earth-based teams to ensure a safe and smooth operation. The Nucleus VR solution allows the Earth-based specialists to virtually teleport to the ISS and collaborate with the astronauts in real time.
So here you
the
see
digital twin of the spacecraft creates a virtual meeting place, allowing astronauts and Earth-based specialists to access the most up-to-date information in an immersive and natural way. The Earth-based engineer wearing an HTC Vive is immersed in the ISS's digital twin.
So this is the astronaut wearing a HoloLens.
Here you can see the astronaut wearing a Microsoft HoloLens.
So he can see the environment around him. And also,
the astronaut sees the engineer as an avatar, facilitating easy and natural collaboration. They can work together as if he were actually right there next to him in the ISS.
So basically the expert, myself in this case, wearing a virtual
Three
headset,
European
is
Space
guiding
Agency
the astronaut how to
Reinhold
fix
Ewald,
something.
Leopold Eyharts,
So yeah,
and
we were
Doran
very
Dimitriou
lucky to meet
Prunariu
all
were
these
able to test the
astronauts and
Nucleus VR
experts that
digital
help
twin
us
solution and confirmed its
develop this
usefulness and
idea.
potential for space
But basically, it's
exploration
really
operations.
just using our
The technology created
product.
by Nucleus VR has won the prestigious European Space
maybe,
Agency's
Natalie, you can
2018
stop the video now. I'll go back to the slides. So next slide. How does it work? So the idea in our system, we feed in 3D data from CAD. So basically it's engineering data. And we basically connect to this digital twin of data via headsets or tablets or whatever. Many people can connect together. The problem is that with the ISS is that this the inside of the ISS is constantly changing. There's new experiments every few days, and there's moving stuff around, and it's difficult to keep track with these changes. So we need something better than just a CAD model, a static 3D model. So this is where we started collaborating with Andre a bit less than a year ago to use the AI box to do scanning, to be able to have an interactive and dynamic 3D model that is updated regularly. So for this, the plan is to use photogrammetry. Basically, the principle is you take loads of pictures, and from this you can rebuild automatically a 3D model and use this in conjunction with some new scanning cameras. There's quite a lot going on, and this is a sector that's moving very fast. The thing is that this photogrammetry uses a lot of calculation. Basically, it's very intensive in the CPU, and also you need astronauts to take the picture. So the idea is with the AI box, basically we have edge computing. The AI box can do all the image processing and object recognition, and it has the high-speed downlink to send the data back to Earth. But the good thing is once you've processed the data with edge computing, it's very small. The result, you only send the result, which is very small and compressed. So for the computing, we're okay. And the other point is astronauts, basically their hourly rate is very high. The cost of asking an astronaut to take pictures would be completely impossible. So for this, we are investigating to connect up to these mobile robots that are on board the ISS. So here on the left, we have Sphere, which is the older version that's been up there maybe for 10 years already. And then there's the European version done by DLR and Airbus, Simon, Astrobee, and a Japanese version of a robot. I don't know the name of this one, which is only recently heard about it. But basically, the ISS is equipped with these devices already. They're already on board. The idea is, here's the complete system. So we have on board the ISS the IceCube system that can communicate with the robot. So this robot is perpetually scanning, taking pictures, and from these pictures we rebuild the 3D model. It's also connected to the astronauts' AR devices such as HoloLens. And the service is to connect back down to Earth also. So we have the edge computing going on here, and then we have a small, all the minimal amount of information is transferred to the ground station on Earth via the IceCube infrastructure, which communicates with their base station. And from there, we can connect to basically remote experts like other astronauts that will be able to help on board. Maybe you can imagine scientists that will be able to help the astronauts manipulate the experiments on board, or maybe manipulate the experiments directly. And why not also like big meeting rooms? This is a picture of the CDF, for example. where you have a whole group of people that are assisting the astronauts or an experiment. This could be in case of a Apollo 13 scenario, for example. So you see, without basically without ice cubes, this would be very complex for us. So this really facilitates the work. And yeah, so we've been working on this for years trying to get this into space. So definitely ice cubes for us is the easiest route to do this. So yeah, that's about it. So there's many applications with this system. And as you know, like as Andre explained, like the commercial space is starting to grow very quickly. And if all goes to plan, it will be very big very soon. And there will be a very big need for remote expertise and communicating between Earth and, for example, the Moon or Mars. And the fact that you can do edge computing will kind of enable transferring a lot of data in very small packets, which are really prepared and pre-computed to be as small as possible. So yeah, we're looking forward to all this advancing rapidly. That's about it for me. Yeah, thank you very much.
Thank you very much, Alexander, and thank you very much, Andre, for this amazing presentation. If you have any question, you can write it on the chat. I had one. The first one was what are COTS components, but Alexander translate what COTS means, commercial off the shelf. The second question from this definition is why do we have COTS component if there is a cheaper than other components? Why is the difference between a COTS component and not COTS component? I guess, Andre, you can answer to this for us.
Well, I mean, if we're talking about space systems and space capabilities, until recently it was just, I mean, everything was, let's call it custom made. I mean, every project kind of starts from scratch. But now with the commercialization part and with things being repeated and done over and over again and being done in a reusable and repeatable way, then you can use basically the same components that have been tested for the same type of activity. So there's also, this is basically sub-markets and sub-opportunities that grow out of these needs, because you will have you already have processors that are being hardened for space and all sorts of components that are already out there. So you can basically buy some components online and just assemble your satellite. Sure, it takes a lot of work in putting it together and testing it, but things are definitely much, much easier than they were some years ago.
Okay, yep. Thank you for the answer.
If I want,
yeah, Alexander?
Yep, it's also valid for software. So we've been in touch with the European Space Agency, and one of the I'm not quite sure what the name of the program is, but it's like technical development or something. I can't remember the exact name, but concerning VR and AR, they are looking for existing technologies rather than starting from scratch. So if the idea is they want to use industrial, already used technologies which have been used by many people already. So it's more robust if you know that, like, the whole of, I don't know, Volkswagen or Renault are using it. They know it works already, because if they start from scratch, well, they'll have to do everything and it's going to be complicated and expensive. So this is part of our approach towards ESA, is to demonstrate that our technology is already used in industrial sectors.
Okay, great. Thanks for the answer. I thought about the cost components like generic medicines, but it's quite different approach. Thank you. I have another question for you, Andre. I would like to know what is the process to collaborate with you, because I'm not sure that everyone knows that the ISS is accessible to your ice cubes. So how people come to you and say, I would like to develop some services, what kind of solution you can bring to us? Or are you more aggressive and you have to evangelize your solution?
So no, we try to be, we try to stay open and flexible. So I wouldn't say we have a procedure, but of course it depends on the activity and the experiment. So the simplest way is to just drop us an email so we can talk about the idea. But if you go to the IceCube's service website, you can also find some useful documents and some resources to learn a little bit about capabilities beforehand. And we also use this, there's an experiment questionnaire that we use, and an applicant or a potential customer can just fill it in. But then, of course, the questionnaire kind of requires that you have a clear idea of your experiment. But if someone simply wants to explore ideas or synergies or what can be done, we can just simply organize a call. That's it. It's as simple as that.
Okay, great. I have a question for you, Alexander. Who is using your service right now? Is that in which countries? And what kind of user? The astronaut or scientist and so on? Who is using your solution?
Okay, yeah. So as I mentioned, it's not actually used in space yet. So that's what we're really working on. So that takes a long time. But our main customers, so they're on Earth in France mostly. So we have, for example, BIC. These everybody knows these. So this is a French company. They designed their own machines for producing these pens, and these machines are used all over the world. So basically, there's a lot of work in the design where our tool is used. So on another aspect is like the engineering side of our tool, but also the remote expert to fix these machines abroad. So they have like a production site in Mexico. So this is used on a daily basis, I'd say. And then our big other sector, well, I can talk about mostly, well, I said nuclear industry. So this is quite similar to space, whereas you have people working in constrained environments, and you cannot mistakes are not possible. You have to get it right. These people are put in extreme conditions, so they have to be trained first very efficiently. When you have like a repair work or something like this, everything has to be prepared step by step, very precisely. And our system enables this. Basically, you have, rather than having the digital twin of the ISS, you have the digital twin of the nuclear reactor, for example. So the guys can train in here and communicate when they're doing this work with remote experts. So yeah, and then we have other customers in industry, like for example, steel works. So the steel industry, making big sheets of steel with massive machines. It's like a 24-hour-a-day process, and they use it because they need to plan to be able to change machinery in a very short time. There's a 2-week production stop, so everything has to be perfect, so they can change this extremely complex machine in 2 weeks and not get it wrong. So it's a lot about anticipation and planning, and communication also.
Great, thank you, Alexander. I have no more question. I don't know if you want to add some subject, or if you have any question or remark you want to add.
David, maybe you have some questions for us, or maybe things we can clarify or bring more detail to, because I mean the whole idea behind a Newspace webinar about challenges and opportunities is to kind of to communicate towards non-space segments and sectors, and pun intended, to bring space closer to Earth, or back to Earth, because part of our philosophy is to integrate microgravity and space into Earth activities and Earth markets and the Earth value chain. So there is a lot of work that needs to be done when we communicate towards potential customers and segments that don't really know what's in there for them. So they don't really know, they don't necessarily understand the connection between what they do in their lab or in their facility and space. But the more you dig into it, the more obvious it is how that it's basically a whole new industrial layer that will boost the capabilities on Earth. So it's not space and Earth stuff. It's not separate anymore. It's basically like a natural, it's like a natural evolution of Earth markets. It's not a separate layer anymore. It's just everything together. And I showed you the first picture with the space sector, the space economy. It's a relatively small sector compared to the largest and the biggest industrial sectors and the biggest markets in the world. I mean, $370 billion is not that much, considering all the space-based applications and capabilities we use on a daily basis, things that we already take for granted. We don't even, exactly. So compared to other sectors, this is nothing, and everything goes in here, including exploration, and including all these. And I think part of the communication part and part of the message is all the spin-off technologies. I don't have any slide on that at the moment, but there is a very long list of technologies that were basically spun off out of space technologies. So medical applications and new ideas in the automotive sector, and it's just a very long list of Earth technologies that were basically born out of the Apollo era. And what I wanted to add, and what's super interesting right now, is that some decades ago, during the Apollo times, it was space technologies that pushed for the development of other terrestrial technologies. But now it's kind of the other way around, because Earth technologies have evolved so quickly, and we have this exponential growth in all sectors. But because space projects are usually, they take long, and they're super complicated and sophisticated, and it takes a long time to validate, to certify, to make sure that everything works. It means that the space technologies are kind of lagging behind compared to the rhythm that we see on Earth. So that's very interesting. That was the whole point. That was the whole idea of connecting Industry 4.0 and all the most cutting-edge technologies we have with space assets. Because when you think about space, you think about the most futuristic stuff. But in reality, it's not that cutting edge anymore. Without casting any shadow on space technologies by no means. This is how this is the pulse, the dynamics. I kind of went.
Definitely. Space is very high tech, but they cannot reinvent everything from scratch better than everybody else. It's just not possible. So, one example is on the ISS, they use a lot of iPads. The Apple iPad, it just works. It's reliable. So this is why there's a big will from the European Space Agency to get people from every industry aboard with them, because they need this. They need to save time. They need to save money. And when I visited, when I had a meeting there, the person in charge was really saying, I want to meet more Industry 4.0 people. They kind of work a bit in silos, and they want to change this. And they're doing their best to get people in. Of course, they don't have an unlimited amount of time to see everybody, but what I recommend is definitely try and get in touch. They have a lot of opportunities, what do you call them, programs, and some funding and all sorts of things. Also innovation contests like what we did. So this is a bit of a message for everybody at Minalogique, or whoever's watching this, is just do like us, just have a go, and you never know, it may work. So it's definitely not at all as closed as I imagined a few years ago. So yep, it's very motivating working for space projects. So definitely I recommend everybody tries and get involved.
Thank you very much for these words, Andre and Alexander. I guess it's our conclusion. Thank you to take part of this cycle of webinars and to widespread the right words to our ecosystem, because I'm convinced that space may be a huge opportunity for traditional and terrestrial industries. So thank you for these talks, and I hope I see you next month for the next webinar with us. So thank you again, Andre, and thank you, Alexander. Goodbye.